Hello everybody, welcome to another stream. How's it going? So, last stream we ported over the block compressed BC1, BC3, BC4 and BC5 block compressed code that can run on GPUs into our code base. It's all ported over now. And the objective today is to get those block compressed functions being called from a couple of shaders, which will actually do the block compression. So we haven't really made the shaders for them yet. So here's what we're seeing is we're seeing like effectively the uncompressed data being uploaded to a compressed image, and we're seeing those compressed blocks basically show a bunch of random information. Now, what we're seeing that is more organized is the normal map underneath. And that's what we're seeing, which is more organized here. So, yeah, the objective today is to get the materials rendering again. So we'll start off by making those shaders. So I'll find just a compute shader, we'll give it a search, and I think we can say, you know, compress BC1. That'll be our first one. So we compress BC1, so we'll see what we can find here. So I might make a section for this. Visibility buffer, GPU. That should be material really at some point. Right. Yeah, I think we'll make another section for this. Oh, this is shared though. Yeah, okay. Block compressed. Block compressed. Right, so these are the push constants which get uploaded from the CPU to the GPU. So we'll call that compress BC1, BC for bundle constants, as we call them. So what I'm thinking about doing here is we need an input texture. So read-only texture 2D. Yeah, I guess this is like, hey, compress BC1 2D. Yeah, I guess we need a 3D one, we could do that. They're probably always just gonna be 2D. Maybe. We'll see. So this one would need to be format A UNOR. Right? So this will be the input. And then we'll have the output, which will be write only 3232 UINT. And then so we'll have a raw view into a block and be able to write out that 4x4 set of pixels. Hey there, Myvar. How's it going? How you doing? Welcome, welcome. So we'll probably want some like dims, I guess we'll call it. It's the input dimensions. So we need them for BC 4. 3, 4, and 5. C4 and C5. So BC3. Okay, no, let's get started on BC4 first. BC4 would be 8 UNOR. Right, single channel. But it's expressed in, its output is a 64-bit per block. So that's two 32s stuck together. A BC5 is two BC4s. So that is actually a 32. So that's 128 bits. So 16 bytes. And then the same story is for BC3. BC3 includes the alpha channel, which means, and the alpha channel is encoded as BC4. So it needs it's BC1 and BC4 together basically. So yeah, those are the ones we're gonna make, and then we should just be able to call them from CPU side and be able to make these block compressed textures all on the GPU. Been a while, chugging along. So you sorted out the normal. Yeah. Yeah, I end up going to tangent space normals in the end. I managed to get those working, and I went back to using just standard spherical mapping. So I'm not using the octahedral map anymore. So it's pretty neat. Because I'm making all my textures on the GPU based on the normal. So I don't have to worry about the poles basically, because I'm using the sphere normal, and the texture encoding or the UV mapping doesn't obviously create that problem, which is something I completely underlooked initially. Right. So it was like compress BC1. So I think, right, we should just be able to get a BC1 block. So this is launching an 8x8. Right. Oh, I've got to do the swizzle thing. Something like that would do. So we're going 8x8. If we go out of bounds, we're not going to do anything. It's rounded to a block though. Yeah. Rounded to the block dimension. So we get BC1 block, that just houses all of the uncompressed pixels for a block. So we'll just call it block. So we should be able to say BC1 block load, pass in the texture, which would be BC input, the inverse texture width. So this only supports square textures. Is that going to be a problem? Yeah, I wonder. We could... Yeah, I think it's a bit silly limiting it to... So we will say... I don't think it's the end of the world. Yeah, we'll change this. We'll just call it texture dims. Then I think what we can do is cast that to a float. And then obviously divide instead. Like so. That'll be... Right, it's going to require a bit of a code massage, but shouldn't be too bad. So we just want to scale. So 2 divided by. So I think it's sdiv 2 cast of texture dims. Alright, that'll be better. So let's go around and quickly just fix those all up. Oh, I've got an extra semicolon on there, let's get rid of that. Right, so there's an offset. So this is about sampling a 4x4 block. So that's all it's doing with the gathers. Right. So that takes in a U32 times 2 texture dims. Amazing. Right. So BC4 and BC5, then I just got to fix the offset, and then we get back to writing the shaders. So offset.x, offset.y, .y then .x, .x, .y, .x, .y. Right, so back to the actual shader code. Now, so compress BC1, we load in a block. Now I've made this better now, so it takes in just BC dims, which is just a 2-dimensional. Well, it's the size of each dimension of the texture in pixels. And then we pass in that dispatch local index, and voila. So, yep. Then this gets us back a BC1 block, so that is just a 4x4 set of pixels. Then all we have to do, hopefully, now I've got to be careful here, so this is an 8x8, and a block is 4x4. So you've got a 2x2 of 4x4 blocks, right? So you've got 4 blocks within a thread group. So what we have to do is figure out like which is the first pixel in a block, and only those ones can write out the actual block. Oh wait, we're kind of skipping ahead. There's one more function to call. So that you do a U32. Well, you know, maybe the way I should have done this, it should actually be dispatched on a per block basis. Each thread in a thread group gets a block. So you've got 8x8 blocks. Yeah, that will be better. Yeah. So what we're interested in doing then is compressing. So doing something like U32 times 2, this would be the compressed block. So you have the raw block, I guess. I'll just call it uncompressed, and then call it compressed. So this would be BC1 compress, passing the uncompressed block. And you get your compressed block back out. So with this, yeah, see, this is where I've got to be careful, so that we're passing in a dispatch local index. And then it loads a 4x4. Ah, it's multiplying it by 4, isn't it? Yeah, okay, good. This is it. Right. So what does my wave 32 one do again? See, I called it dispatch local index, but that's a bit wrong, isn't it? It should be the dispatch index. What are they using that code again? I wonder what name they used. And why I've put that name there. Yeah, so, you know, theirs didn't have a sort of a load BC1 block, did they? Right, thread ID within dispatch. Right, yeah, I just named that wrong then. Yeah, so this is just the dispatch index, basically. So that's a bit of a terrible name because that's just imposing on how you're. So what we're trying to say is like, what is your block index maybe? It's a better one, isn't it? Okay. So in terms of like working out what is our block index, we don't really have to do the Morton swizzle, is that right? It might be better if we do it that way. Doesn't really matter though much. Right. It maybe helps with writing it out to main memory. So we put the two-dimensional block index in there, and that'll load all the uncompressed data. We compress it, and then we write it out into, so it's store texture 2D 3232 units. So I've not used this one before and I can't see it for some reason. I have no idea why. Probably because right, that should have got it all sorted out, so maybe texture 2D format 3232 unit. It does exist. Okay, good. Right, so I don't have to go and change that, which is great. So that's the BC. So BC doesn't have a block compressor, it stands for bundle constants. So there are push constants, basically. So we're going to output texture, which is the block. So the compressed blocks is a 4x4 set of pixels compressed as BC1. And then we output that at. Why does it take it in a 3D index? What is going on there? No, that's because I loaded the other one. yes, to the index. Right, so that'll be block index, and the value will be compressed. So that should be BC1. Right, now the rest are kind of effectively the same. So it should just be a case of cut paste. So yeah, those who were joining not so long ago, there's a BC1 push constants which has the uncompressed input texture. Here's the output compressed texture. And so this is RGB. BC3 is RGBA. BC4 is just R, it's just a grayscale texture. And BC5 is RG, so it's a 2-channel texture. So yeah, BC3 is a combination of BC4 and BC1. BC4 for the alpha, and BC3 for the RGB. And then BC5 is just 2 BC4s. So, should be a case of just changing these out, these numbers here. So that's a 3, go to C1, so C3. Now this will have to use a 4, and this is 32, 32, the vector 4 of U32, and voila. So if we take these two here, cut, paste, look for C1, and replace that with C4, and that should be everything that we need to change for that one. Then we look for C3, and that should replace with C5, and that should be it as well, because C4 uses 64 bits for a compressed block, whereas C5 will use 128 bits. So that's really great. Let's just double check it compiles, and then it's just a case of changing the material generation code. So this is complaining because we have an undeclared variable, but it's declared, it's just named wrong. Block index. Now dims is interesting, so we should probably we put output dims in, and then yes, that's the output dims. Let's just label that better. So output dims. So another thing as well, now what I've done is passed in I wonder. Yes, maybe this one should be multiplied by 4 basically. So this will be basically multiply BC output dims by 4. Okay. So we give that a run. Oh, maybe not. What's going on here? Did I not save everything? Oh. Right. Maybe I didn't change it for every single one of those. Yeah, I didn't do it on all of them. Alright. Here we go. Right. What's happening here? What's going on? Was this BC what? Oh, okay. It wants a sample texture. Right. So yeah, we need to switch that for sample textures now. Makes it a little bit more flexible in the type of shader it is as well. This is just be a float. And the other one will be a float too. So vector 2. That'll do it. Alright, so does that compile? Right, looks like it's compiling now, so that's good. So now we've got the shaders, now we've just got to kick them off. So again, this is us viewing random data basically. Well, it's viewing the uncompressed data being uploaded to the compressed textures. We're just seeing a bunch of blocks effectively. So we're hoping to fill these in with proper data from the materials which are generated on the GPU. So we're going to go to where those materials are being generated. So I think I've called it test material, and this is the current block of code which runs this. It's just a test material past 0 is where our fractal noise virtual machine is, which basically allows us to pass in a bunch of instructions and get a material out. So we've made some in the past with this. These ones, these are the current ones. So this sort of like volcanic ground looking one. I've made a better one in the past, but this is just another one I've just thrown together quickly. This sort of like rocky looking hair thing with a comb over. This is showing two different materials being overlaid with some blending. They then obviously get compressed into a single material at the end. And then this is just showing a very reflective metal. Just show the normal maps, but they're a little bit bad though. I need to maybe improve the way we generate these. So that's what we're going to try and get up and running again, but with block compress. So this generates the albedo emissive, roughness metal, height, and normal. So that's all pretty legit. This pass one will generate the normal map. Then we do downsample all of the things, and then we expect them to just work. Now, this is where we need to put our block compress shaders. Now I just got to figure out where we do this. So here's the thing. Yeah, so block compression this is the material cache, which has like arrays of textures basically. Whereas a single texture with a bunch of array layers in it. So is it block compressed or not compressed based on the option there. Then I've got another one which is this material texture, which is for basically generating. And is that what we want it for, is generating? I think so. So I probably want an option passed in to say, for this material texture, do I want it in? Yeah, probably as a Boolean. Or I've got it as like graphics material. Something like this, right? So we make it an input. Right, so I think we can have our sort of uncompressed and our compressed version. So these will just be used when it comes to generating materials. So uncompressed and then compressed, right? So this would be a sort of I think it's called a V0 graphics. Material compression off, and this be compression on. All right. So what will be next is where we ended up using these. So I used it here, right? So I think I want to call this M uncompressed. So an uncompressed texture going in as our material that we use to generate. Then they obviously downsample the crap out of these. Then afterwards we need to get hold of the compressed material, which has all the different material properties. Then we need to say, right, this is, yeah, this is where we run all the shaders now. So yeah, we need to say so I could probably say I make some functions called like graphics compress BC1, and that will dispatch one of those. So I think I can make little functions for those. So a bit like we've got graphics downsample, perhaps. What we can do is have little functions like compress BC1, and this is just saying, okay, what is that sort of input and what is the output? And then we can probably have some nice asserts in there as well, just in case you get it the wrong way around, right? Oh wait, usually it's the other way around, right? It's destination and source, right? As we program it in C, 3, 4, 5. So I think we can make these quite easily. So I reckon we want to straight off the bat do an assert, and that assert will be GPU texture format. Have I got a way to get that? I don't know if I do have a way to get that. Hang on a minute. Yeah, I don't have a way to get it. So we should look into that. GPU format, GPU texture format. I don't really have a textile buffer, so for now, this will work. This naming will be fine. So just throw this in. Rightio, so we've got this nice little function now. So this means we can just say, right, the output must be GPU format BC1. There's only sRGB in it. That makes sense. Yep, and then the input texture must be, it could be anything really, but it's got to have 4 channels. And it must be a floating point 4 channel one really, but yeah. output texture must be sRGB. Or must be BC1. Right, so the input must be 4chan. Well, it doesn't have to be. Right, just leave it like that. So BC3, let's just write this one out fully. So we'll say G graphics, compute shader, compress, BC1. Which is the bundle constants. We'll zero initialize these. The input is equal to GPU sync read-only on input, and then read-write on the output. Then we obviously need some output DIMMs. So this is where we need to probably get both of the DIMMs here. I could have already passed both of them in, to be honest. Yeah, let's pass both of them up to the shaders, it will be better. It's just wasted otherwise. So we need the output DIMMs. So that'll be GPU texture DIMMs 2. Output. And then we'll have obviously the input. So in the shader code, let's just quickly fix that up. Rather than having to do this, or we multiply it by 4 or whatever, we should just be able to say, right, BC input DIMMs. That would be ideal. So we'll just quickly throw that one in. So should probably put the output first. Right, so I reckon we can do something like, right, we'll look for output, replace with input. Nice. Cool, so I'm glad that's corrected and made a bit better there. So the next thing is we need to obviously put these in the bundled constants, and then after that it's just a simple case of dispatching. But we should probably make sure that we assert that that's all of the components in output DIMMs and input DIMMs are equal to each other. And we're not equal. Hang on a minute. We need to be scaling. Oh yeah, we want to be equal, right? Yeah. So those are in pixels. Yeah, super nice, lovely readable message. So that would be output DIMMs.x, output DIMMs.y, and then input DIMMs.x, and then input DIMMs.y. Cool. So that's great and everything, but we've got to be careful because output DIMMs is actually in blocks, since this is accessed as a storage buffer. So we need to divide by 4. Yep. Rightio. Final thing, GPU dispatch. Now the shader is HCC shader, graphics compute shader, compress BC1. Nice. Number of groups. Number of groups will be a divided roundup of the BC output DIMMs, the ones which have already been divided by 4. We need to divide them by a further 8 because we are launching 8 by 8s, and that should cover the whole texture. So it's the X and the Y. And then we have 1 in the third dimension. The bundle constants goes in with address of BC and size of BC, just like so. So that should be effectively the rest of them. They are just some variation of this code here. So that goes in there, that goes in there, that goes in there. So we look for C1, replace with C3. And that should be it. Next one is C4, then replace with C4. Final one is C5. Now those textured so they're UNorm rather than sRGB, these two, because these are like grayscale. Well, BC4 is grayscale, BC5 is 2 grayscales together, so RMG. Nice. Cool, so now we've got these lovely little functions. When we can simply, when we go over to that sort of test material, what it's called. Now after we've generated our material, we've then generated the normal map, then downsampled everything to 1 by 1. We can now go over all of the textures and generate I gotta be really careful here. Doesn't each MIP level have a view, isn't it? I think it does. So let's just do the first MIP, and we can think about the rest. So, because these are a full MIP chain basically. But right, we want to BC compress, so it's graphics, compress, BC1. The output will be M compressed albedo, and the input will be M uncompressed albedo. So then we repeat that for however many we have. So after albedo, there is emissive. Then after emissive, we have metalness roughness. And then I think that's basically it for our block compress stuff. So emissive is BC3 because it's got the alpha channel. And metalness and roughness is BC5 because it's 2 grayscale channels stuck together in a single texture. Cool. So if we try that, that should output to the MIP 0. But it won't do all of the MIPs, so we should at least see something working here. Maybe, let me just double check. So I'm looking for the material texture. Right, here's where we load in a material, and currently we haven't got an asset file where we load them in, but we'll get that very soon after we've done block compressed. The next thing we are working on is the asset building system for this stuff. So this is we want to be using the compressed lot here. Now my concern is that we haven't actually got the normal map and that in here, actually thinking about it. So what we should do, maybe this graphics material texture needs to just have the uncompressed and compressed in a single strut. Right, let me just do the old. Right, so height. We don't really care about height, to be honest. Wait, but did we copy it? That is the question. Height and normal. Yeah, okay, we'll do it. Right, so height and normal, we'll make those use compressed for now. And that'll be the hacky way around it. Alright. Here we go. So hopefully this is what we're looking for, maybe. It's sort of what we're looking for. We just made it look even cooler than it was looking before, not gonna lie. It's looking way better than what it's supposed to be looking like. So this is the... It's this one, but it's got a bunch of like... Yeah, I don't know what's going on. Yeah, it's very bizarre. There's the normal map. The normal map actually has a pattern on it now. Interesting. Albedo's corrupt as hell. Emissive is also corrupt as hell. Melness roughness is okay, I think. So I think our BC1 is messed up. Let's change to a different texture where it's probably better. Shaders. Then we go to the bottom. There's our custom material pass. And if we enable submaterial 1, let's get a different one. No, we're looking at the volcano one. Oh yeah, these are already messed up. Everything's messed up about these. Right, this is that hair looking one. Looks very metally to me, doesn't it? Green. But hey, at least these things are running. So effectively we're... Yeah. They could be anything wrong in these shaders. But yeah, I think they're all broken. Which is to be expected, to be honest. These are our blocks. So if we take a look at these blocks... Yeah, they seem to be like... a very... Every other block just ends up being completely different. It's as if they follow a pattern, right? It's kind of odd and even in a sense. It's like a grid. This kind of could help what's going on, maybe. It's just green. No red channel. It's interesting. So, where will we start solving this problem? Yeah, Minecraft compression format, exactly. But it's from Microsoft. So we go over to BC5 is 2 BC4 blocks, and then yeah, so I guess the thing to look at is like, is the input data fine? Took a screenshot. Right. So the next one up should be it. Yes, here's the input texture. Looks alright. Where the blending happens at the top, we expect that. So if we see in the other texture, this is what it ends up like. So yeah, completely off. So input input texture fine. So I wonder if it's all this sort of coordinate stuff, maybe. Hard to know. Maybe we'll start with BC1. But we are writing out to every single block, right? So that's interesting. Every block is getting written out to, so that's not the problem. Do you like Helix? I've been using Vim and Emacs for over a decade now, thinking of trying something new. Yeah, so I switched to Helix because my NeoVim config broke when I updated some of the plugins I was using. So I was on Vim before, but I thought I'd try out all the new stuff in NeoVim to see what it was like. It just kind of made Vim a little bit more heavyweight and, relying on the language server protocol. It was alright. I think, yeah, there's some things in Vim which are just a bit nicer. Like, I think the language server protocol doesn't really fit the C programming model very well. So I went to, in Helix and in Helix and in the new replacement of Vim, right? They're very reliant on the language server protocol, so it doesn't really end up finding all the best results sometimes. But yeah, Helix is great because the config is very simple. It's just a config file. It's not like a programming language, so it's quite fun. You don't really have the ability to go crazy in that config file, which is great. Yeah, it comes built in with like some of the stuff from NeoVim. Like you can press space and then press F and it's got the file picker. You can do global searches, you can do search through your buffers, and you can even search through commands by pressing question mark after space and search for any command and see exactly what key it's bound to. So yeah, it's quite nice. I quite like it, but the only reason I switched to it is because my Vim broke, right? But yeah, this is the config file. It's just an example of it. I've had to rebind everything because it is a Comac keyboard layout. But yeah, if you're looking around for a new editor, it's quite a good one, Helix. Like if you want to jump into like a modal editor for the first time, it's quite good. But if you have something set up, then yeah, maybe. I can't tell you how much of my life I've lost to Niven configs elisp. A text editor. Yeah. Yeah, exactly. Like, this is what I was really looking for, is a Vim-like editor which didn't have... You didn't have to invest a lot of time in setting up. Like, I only had to spend time setting up because I use a different keyboard layout. So, that comes really well set up with like a language server protocol and everything, which, again, it doesn't really work the best in C-based languages, but it does the job. So yeah, I don't know what's going on. I think it could be that all this stuff is just swizzled wrong. So I'm wondering, or it could be the compression code. So how would you solve this problem? Well, or how did you figure it out? Well, what you can do is you can rewrite out the same texture to where it was read from. So you read it all in and you write it back out again. And then we can know whether or not... Yeah, that'll do it. Then we can know whether or not the sample code is working as we expect. Yeah. I just wonder... It's definitely picking up the pixel colors fine. So it could be the ordering. We'll see. Right, I'm just gonna take a quick break, and then we'll come back. We'll write our test, like a for loop to like write it all back out again. We'll see how that goes. Right. BRB. Right, welcome back, everybody. So, yeah, our block compressed texture format looks a bit weird. All of our blocks look a little bit strange. Yeah, I wonder, right? Let's look at that again. It seems like there are pixels, but they're... Yeah. Yeah, it seems like we're seeing pixels, not blocks, though, right? Oh, no, we are seeing blocks. Yeah, but they look a bit strange. Okay, super strange. That's just all like... So the uncompressed one is here. Yeah, so obviously this one is going to be basically a couple of tight. The shade is completely off though, as well. So I'm wondering if that is because... Yeah, I wonder what that's because. What is that because? Well, we are doing some silly swizzling thing as well, aren't we? But that shouldn't matter. But yeah, the tone is completely off. I've always seen any bright areas that we are right here. So do these compare to these? Looks somewhat similar tone, I guess, but oh, there's some brighter areas. So we are sampling it, right? And it won't be an sRGB, will it? Oh no, it will. Yeah, it will sample it into linear space. So if it sampled it... I've not got a way to do anything there. So if it samples it into... That's what gather will do, wouldn't it? Gather will... No, it won't. What will it do? Yeah, I guess we won't probably fixing that problem yet. Let's try and get the pixels looking right. So, yeah, the pixels just looking completely wrong. So, why don't we try and take that block and write it back out in the exact same place? So, if we go to block load, let's change this out to a... Crap. So I have one called input 2, read write texture format 888 8 unom, yeah. Right. So the plan is, when you're on compressed block, we're just gonna literally write out some test code, which will write out the uncompressed block back into memory. So it's gonna be, you'll get your sort of pixel, which will be, yeah. So we want to make one of them. Yeah. So you do like a. We need to do probably a 2D for loop. So y 0 to 4, then x 0 to 4. And what we're looking at achieving is we need some form of like writing coordinate. So that'll be effectively y. Sorry, I meant to say x. X plus block index dot x times 4 plus y. Sorry, with y plus block index y times 4. And then the color is going to be uncompressed dot text source, right, y times 4 plus x. Oh, hang on a minute, that's going to get you the c dot RGB, right, because that text source is, yeah, vector 3, then c dot a equal 1. Now the final thing is we just store out to texture 2D of AAA unon. And then it's in BC input 2, I've called it. The index is coordinate and the value is C. All right. So that's what we're going to try and do, see what happens. So we need to go to graphics, and where we do BC1 temporarily, we're just going to do another one, call it input 2 with an read write sync, and voila. So hopefully this works out all right. Okay, so we pull up the texture viewer. We'll see the uncompressed one, which is this one here. Right, so it's just darker, right? And that's because obviously we didn't write it, we didn't do the sRGB conversion again. So Gather does do the sRGB conversion to linear. Right, so we've got to be careful about that. But it seemed like the pixel locations are fine, right? So it seems like the sampling code, or as soon as gathers, is fine. If I quickly go and run the BC1, yeah, if I run this code here, which generates the texture in that every single frame, it's going to be expensive and make the stream lag a bit, but hey ho. Right. I think the stream is still coping. 10 FPS maybe. It's alright, let's keep going. Let me know if the audio is breaking up or anything. Right. So here it is before. And then we write it back in the exact same space. Yeah, there we go. Before and then after. Before, after. So obviously it's just the sRGB thing there, but the pixel's being written back into the exact same place. Why else am I looking here? I just wanted to double check that, right, basically. Right, stream should be back. We're good. So, I reckon. So yeah, that's good to know, it's good to know, good to know. So maybe we can undo some of this stuff now. Go to shaders. Hey Alchemist Adam, welcome, welcome. Awesome, good to know. Appreciate it. Yeah, I didn't know that before. Good to know. So, this data is all fine. So it must mean then that this load code is great. Except for the sRGB is a bit off, but again, we can worry about fixing that in just a sec. Our next problem is something is up with this block compressed code. So what we're going to do is we're going to dig into the Yeah, it's just something is just painfully wrong with this. So we'll go into the original source code that we acquired it from, which is Microsoft, believe it or not. So I've put them in the document of to people to acknowledge for thank you for stealing their source code. It's all under the MIT license, which is great. Hey Voodoo, how's it going? Yeah, I'm doing alright, just, as usual, extremely tired. But a weekend is approaching, so I will be able to get some sleep soon, hopefully. But yeah, things going alright. I'm moving to a new team soon at work, so I've been moved to another team, which is interesting. It's a bit sad leaving my current team, but yeah, it's gonna be weird and different, I would say. So yeah, going for that at the moment, but other than that, things at work are going pretty cool. Just started on my new task, and I'm having so much fun with it. Been doing some performance improvements, basically. I can't go into specific details with things at work, but I can give you general talk about like things from a very vague point of view, but just doing a bunch of like performance improvements on something, and it's just, there's two things I really like about programming is researching about how fast stuff can go and how to make it better, but also like packing stuff down into as small space as possible. That's what I like doing. But yeah, I hope it turned out cool too. Yeah, the team is really, they're nice people. It's just I like where I currently am. Just it's the way it is. Yeah, based interests. Yeah. But yeah, how's things going with you? How's life? Yeah, it's my birthday soon as well. It's my birthday in 7 days next week, so I probably won't be here next Thursday because I'll take some time off, spend it with the family, or go and eat. I think I'll go to the gym, eat some food. Fun. I'll be the big 3-0. So no longer a young'un. So this was that inset thing. Let's have a look at that inset code. So we could disable the inset code and that could tell us that the inset code is fine or not, but let's just double check instead. So multiply by 1 divided by 16. Subtract the min from the max. Good. Alright, I start working on a voxel game for uni. Amazing. Need to make it multi-threaded or else it'll run like crap. Will it? Maybe. It depends on the hardware you run it on. I guess you're doing a lot of stuff CPU side to do the rendering. Like if you used to get all your voxels, are they all being generated on the CPU side, basically? No, like you do the greedy meshing thing, is that what you're doing? Yeah, okay. I see what you're saying. Yeah, depends how you do your... Yeah, depends how you do it. Let's go back to Nick Johnson. Man. And I think it started to like this one go at uni too. Amazing. Go up and say hi. Yeah, it's always scary with girls and stuff. What I find is don't go seeking for it. and just live your life and try and just focus on yourself, and you will find someone that way. Like when you're trying to look for someone, for me, is always just like a real bad experience. I just met my wife randomly, and you know, I find if you're trying to like go out and look for someone, like for whatever means, you're gonna find people who are probably not the best as well. I think you probably find better people just by naturally living your life, if you will. Yeah. But yeah, if you oh, I hope it all goes well if you approach and say hi. See, the inset's looking alright, I think. That's gotta take offset. And we multiply it by this scale. 255. And then when we seal it, to the ceiling you go, my friend. And then divide it. The other one's the other way around, it's an add instead, and that's using the min. Adds the offset, floors it. Oh, sorry, multiplies, floors it, divide. Add, multiplies it, floors it, divides. Good. So that's alright. This next bit of code here is where it gets the indices. So this could be what's wrong. It did look like it was probably the indices that was the problem, because of just the way it was kind of per pixel was wrong. So anyway, we did the pack 565. Let's look at that. I think that's alright. So it's multiplying by these, adding 0.5, then cast to truncate. It's looking alright. Yeah, even at least have a cool project to work on, exactly. This is the way. Alright. So this only gets called if... Yeah, that's right, that's right. Alright, let's have a look here. So diag is a subtraction of that. Then step inc is 3 divided by the dot of diag, dotted with itself. Scale by diag by this. Yep, take max 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 min, step increment. Right, so where's the round? And it rounds at the end, so it's the dot of the current text of that texel and diag plus c. You added 0.5 and just truncated it. Nice. That'd be alright. Bit in is index and bit 1 in, shift right. Whatever this magic is doing. And we all the indices. We essentially indices to 0 as well. Good, good, good. Then if not equal, then go around again. And just return indices. That looks alright. So for crying out loud, that looks completely okay. What is going on? So, could we mess around with the indices? So the indices is basically saying each pixel gets one of the colors. It is finding the best. Well, this code is doing. So the way BC1 works is there's two colors. There's a min and max color basically. And then these are, you can think of these as two 3D coordinates. And then all this is doing is finding the line, the closest point on the line, hence why you got these dot products going on here, right? Is finding the closest point on the line for each of the texels, right? So closest point on line for each. Yes, there's two points in space, and then there's a bunch of texels which will fall on the line between those 2 points, basically. That's all it's doing. And it's spitting out why is it if I is not equal to 0? Oh, it's the final one, isn't it? Yeah, good. Yeah, and this is just the bit pattern basically saying which one it is. Is it min color, max color, or is it somewhere in between those? And there's 4 different options you get. And that's all BC1 is. So, yeah, I haven't checked the code exactly, but it seemed like could. Like, we're definitely a bit off in the RGB sense, though. I think I did mess up because this gives us it in linear space. Um, oh no. They're not in linear because they're sampled in a compute shader. Hang on a minute. What format are these things in? How does this even work in a compute shader? Oh yeah, sorry, you can't use it as a storage texture in a compute shader, but you can as sample texture. So it gets the automatic conversion we're being sampled from. But yeah, we want it to be an sRGB after you sample it. So I guess let's fix that problem first. So it's load. Effectively, these guys here. Need to be prepended with GPU linear to sRGB, even though it's just converted to sRGB. Fast 3. So probably mess up with the blacks. Right. So we try that. The colors should look better now, basically. But the... Oh, I didn't get rid of input 2 in the bundle constants. Let me just remove that. Otherwise I'll forget. As the test texture was outputting. See? Okay. Rightio. So we look at... Yeah, now the colors are looking better. But yeah, just the... So the colors are the right sort of... Yeah, they definitely look right. Here's the original. Yeah. Now we just got a scrambled set of colors. So this... But... So what's interesting, if we isolate maybe this part of the image here, let's say... Let's go ahead and get... I've got tabs for a reason. Yeah, say if we isolate a certain part of an image. I don't know. Though. Yeah, there's like each block. So this is a 4x4 block. So these blocks are kind of paired together nicely. And so are these in a way. But they're obviously wrong still, but they're a 4x4 block and it seems to have some level of smoothness between them. And they completely switch. So that is a wave. Right, an 8x4. That's a wave. So could it be my silly swizzling I'm doing? Potentially. Maybe. So it could be the fact I'm swizzling like a crazy man. But why would no? So swizzling will take every single thread and make it a 2x2. So every 4x4 is a block. So every thread in one of these thread groups gets a block that it writes out. Right, that's what it's doing. So if you have a 2x2, it'll go in 1, 2, 3, 4. That sort of order is a 4x4, 4x4, 4x4. So the first 8x4 is a wave, right? It's 32 threads. But yeah, we saw it when we loaded it and got those texels and put them back out based on the block index, I think. Is that right? Yeah, based on the block index, we wrote it back out in the exact same place and it was fine. We saw that. The sRGB was a bit off, but yeah, we fixed it. So but when you write it out, there's no problem. They're all being... Yeah, it can't be there's anything with the swizzling. That's just changing the order in which it's done. Yeah, that should be alright. Tried changing it though, but... So the other thing is the indices within here could be the wrong way round, but I don't think that's true. Because we took it from supposedly working code. So I wonder what else could be wrong. Let's see if we can take a very... Okay, I got a new idea. Let's output a grid. A 2x2 grid of 4 colors. And that will mean... Yeah. Alright, this is going to be fun. So we'll do, since BC4 is based on a 4x4 set of pixels, let's output a 2x2 grid, 4 different colors, and then that will... Yeah, that would be good. So we'll output basically a grayscale. 2x... Yeah. This. We got this. Right, so let's go to shaders, and we're going to generate... So material 3, let's do material 4. So I think I've got what called fill invalid. Yeah, this is it. So I would like to generate something like this in the albedo. All right, so based on this sort of grid cells, the grid cell is going to be, as I was saying, it's going to be 2x2. But we need to color it, not based on an is on. We need to color it based on... Well, we could do is on. So it would basically make it black or magenta. That's 2 colors. But maybe it's better having... how could we do it? So, or if we did a Morton swizzle, and then ANDed it with 3 to keep the first 4 bits, and that will give us a 2x2, and we'll have 4 different values. And then we can do an interpolation between black and magenta, and that will be a smooth gradient there that we can test working. Yeah, that should be it. So why don't we take a Morton... I think it's something like that. Is that what we do? How did I do the yeah, I think it's the other way around, isn't it? How are these even working? Why is it saying... Yeah, I don't know why one's an integer and one's a float. Because that just turns into an int anyway. Alright, so maybe we should use 1020 for... screw it. Let's just use it. So we're looking at basically getting... It's not going to work with 30-bit Morton though, is it? Well, it could be repeated. So we want to effectively and or mod, just be easier. What is the dim? U-chord with 1024. And then cast that into a float. And then divide by 1024. That's what it wants basically. 0 to 1 value. Cool. So that'll get you your Morton, your index basically, we'll just call it. So if we AND it with 3, you'll keep the first 2 bits. So it gives you 0 to 3, and that'll give you a Z basically. And then all we need to do is lerp between. Gotta be careful here. So I'm thinking, we've already got albedo. So we just say albedo.rgb is equal to lerp between black and unpack color magenta .rgb of index divided by 3. I think the 3 will get you 1. Is the 0 gets you 0, 1 gets you... Might be a bit off here. So 1 divided by 3 gets you a third, right? And then 2 divided by 3 gets you 6. Yeah. Yeah, that's what you want, isn't it? Cool. And that should get us the pattern that we're looking for. Although I'm looking forward to sort of help debug this block thing. I was looking for a vector 3, is it? Well, about that. C dot C dot is 0. Okay, so now we've generated this kind of this grid pattern, which we'll see the grid pattern first before we go and debug anything. Right. I was expecting grid pattern. Don't see it. Don't see rows though. Something's off. What's up with... I think that's what I'm supposed to be then. Hey, Kip Payne. Oh no. It's alright, hold in on there. Or as they say, buy the dip. Yeah, things are, a bit sketchy at the moment these days. You know, but you never know, they could turn around. Problem is, we're still dealing like post-COVID and all that, isn't it? And also, like, leadership in the West hasn't been great for many years. So, I'm okay. I'm not in really now. I did lose all my days, 13k trying to future. Yeah, it's okay. You win some, you lose some. Right. Yeah. Hey, Pete. How's it going? Yeah, it must. It's alright. Yeah, we've all done it in ways. But yeah, how's the wife? How's um the baby making going? That's the way of saying it. How's things going there? What's up, my Y coordinate? Or the X coordinate? What's going on? It's been a swizzle. I don't get what's going on. It's meant to put it in that order of. Or I could go the other way around, right? I could flatten out the. Oh, all I needed to use is the dispatch index because it's already swizzled inside the texture in Morton Swizzle. Right. So all I need to do then is do dispatch local index dot x, and that might be it. Wife's good, baby's still trying. Hopefully the next few months. Wife is stressing over it, but still hanging in there. Awesome. Yeah, best luck too. We're currently in the process of trying to. Had a couple of failed attempts, but we have reason to believe this is a successful one. Finally, we got the pattern. This is what I wanted. I didn't think it looked this cool, but yeah, this is what I wanted. So if you look closely, it's a 2x2 of this gradient. So it's black, slightly more magenta, slightly more magenta, magenta. So why is this great? Because in a 4x4, right, 1, 2, 3, 4, and obviously 1, 2, 3, 4, so this sort of block here, that is the size of a block in BC1, right? That gets compressed together into a single block. So it should help us debug what's going on. We might have to make the blocks a bit bigger though. Wait, no, I made them a 2x2. Ah, I made these a 2x2 set of pixels. In here there's 2x2 of black pixels, 2x2, 2x2, 2x2. So this is just one block of 4x4 pixels. So that should help us debug this. No. So we're already seeing a problem, right? It's just picking the magenta for some reason. And we're going to find out why. So it's just encoded 3 in all of them, I think. So another thing we can do now is put some printing in. and be like, so we hover over a coordinate and just see like what are the indices for that, or yeah, I'm already sampling it. Right, so go to that BC1 compress. So I think what we I wonder what we can do here. Yeah, we should totally print out these indices for the first. GPH printf. So we're trying to say like, hey, these are the indices. And we print that out like that. Now we're probably better off printing it as hex. Wait, compress.y is where the indices are stored. Okay, now we only really want to print this out on the SV dispatch index x equals 0. Right. So we should see that on like the first frame basically. Now I could get it to run every single frame or something like that for a second. So that'd be here we go. Let's just run that every single frame just so we can see it. Hey there, Alid. Oh, Ali David. Hey, just joined 5 minutes ago. Would you please say a few words about what you're coding? I haven't figured it out yet. No worries. So do you know much about block compressed formats on GPUs? So effectively, if you want to use less VRAM, use less memory bandwidth, and so you can render, also you can reduce the amount of the cost of sampling textures basically. There's these formats called block compressed textures like BC1 and BC4. So there's a website on it here which goes over sort of what they are in the formats. And so we essentially have taken some sample code from the repo here, and we've converted it into our code base, which allows us to take uncompressed pixel data, like RGBA data, and turn that into a 4x4 block, which is compressed in BC1, BC3, BC4, and BC5. And we're using that for our material textures that we've generated using a custom shader, which is just purely designed to generate materials for PBR materials. So it's got albedo, emissive, roughness, metalness, and a normal map. So we generate like these things here. Just using some just by changing the shader a little bit, we're able to generate these different things. So it's a very flexible shader which basically uses simplex noise and a noise called Voronoi noise, and it allows us to essentially push on instructions like a virtual machine per pixel, and run them in a shader. Sorry, push on instructions like a kind of virtual machine and run them in a shader per pixel and create some interesting looking textures. So the plan is in maybe like a month or two to have an editor which allows us to sort of do this all live without having to manually write the virtual machine instructions by hand. So it's going to be quite powerful and flexible for an artist to come in and make the material pretty quickly, I would hope. So we're looking at block compressing these things though, because then it will be fast. I'm just trying to get these things to work. Ready? So just trying to figure out what is wrong with our block compressor code. It is definitely not sampling the pixels, they are fine. What is the problem is probably to do with how we're encoding it. So we're just trying to figure out exactly what that is. So, oh yeah, we're seeing it, indices 0. Right, so apparently our min is greater than the, right, so that's the next thing to look at. Yeah, that's confusing. Right, so the other thing is like, let's grab that min code like this, and then let's also grab, yep, let's do that. So that'd be uncompressed. Now, we also want to grab the bit of code which is the packing. And then I want to print out those two basically and see how those look. So min color, max color. Let's print out two colors, min and max. There'll be just two numbers. So min color packed. There's 565, so 5. Yeah. 5 bits for R, 6 bits for green, and 5 bits for red. So let's debug print that. So the first block is going to print out all this information basically. Yeah, I don't know why we're getting 0. It's a bit bizarre. Also, 0 shouldn't be... Oh, interesting. Yeah, so we're getting 0 for min, which is expected, it's black. And then we're getting this for the max color, which should be the magenta. So that seems all right to me. So the next thing is why? So we say if min is less than that, so it's definitely going into here. So oh my days, this looks problematic. What is it? Is that for loop using integer by any chance? It's a reverse loop, isn't it? Yeah, using it. So I've probably messed it up by not using it there. So that loop should never end. Yeah, there you go. We've now got indices. So that loop should never end because, yeah, it's an unsigned int. So I think it just kept on going. And maybe the compiler was allowed to get rid of it because it was an infinite loop. I don't know. Just a guess. Right. This is the BC1 texture and we see pixels that are what we expect. Right. 2x2 set of black, 2x2 set of... Except for this one here is not picking the one in between. So I think it's just the way... Which is okay. That's just a block compressed artifact is that there was no. This was the closest one apparently. This sort of magenta black. Sorry, the magenta was closer than the in between of. Than the 66% magenta was. So what I mean by that, if we go to the this is the uncompressed one. See here how there's an extra shade? But this is, apparently, this magenta here is closer than this one was. So here it is again, yeah. Cool, so that seems to be fine now. So let's go back. So first of all, let me just make sure we fix this on BC4 as well. So yeah, I think we're good. So BC4 is the other one which had to use the int there. So if we go back to BC1 block compress, the shader, let's get rid of all this now. I think we're good. Now let's go over to graphics. Let's go back to shaders actually just quickly, and then at the bottom, we're going to go back to making material, back to 2, and generate a shader that we're expecting to see. And right, so I think this is only gonna, we've only done MIP 0. I did not see it show up. We'll get really close. So let's take a look at the results though. So, still terrible, but it's better. Is that right? I don't know if it is looking better. Okay, maybe we need something more complicated now. It's so weird that it's wide. Right, what do we do next then? As a way to debug this. What's the next way we could debug? Should we go back to the 4? Material 4, which has that shade. Just go to BC1 block compress. So we use int instead. So I guess the next thing we do is we take the indices and we try and see what it right. So it's converting this sort of index And in the mapping like that, right? So I think we need to just take our code and debug the crap out of it with print statements. That's the best we got on GPU. So if we take all this and we'll alright, so that's the block compress for the BC4. So we can manually make sure the indices are right. For a particular block on the screen, maybe. Alright. Let's take this whole function basically. Yeah. So it insets the colors a bit. Pack indices. Generates the indices. So here we can put in all of our print statements and stuff like that. So what are we exactly looking for? So yeah, we're only doing this if we're the first block. Now, yeah, we'll change it around a bit based on the blocks that we want to see. So I think let's print out. Yeah. So we'll print out like, hey, what index did this one get? So we'll just print out like, so it starts on 15, right? So we say, we can work out an X and Y of the block from that end, that I. And then we want to know sort of what index it got in the end, which should be 0 to 3. And 0 to 3 will remap with the code below, basically. So potentially we're better off doing this instead. So this will be I, so cast into U32, I mod 4, where I get the X coordinate, then I, and always divide by 4. I didn't need to cast it, I thought I was going to use bitwise ops, that's why. Cool, so let's see the printed out values we get for these. This will be on the first block at the top left hand side of the screen, I think, or bottom left, which one would it be? I think it's top left because I flipped my textures, but I completely... Anyway. Right, so rather than the block, it's actually uncompressed, it's called. Okay, so we'll see a nice print. Well, okay, I need to run that every single frame. Like so. Right, so we're starting off on the 3x3 block 0, 0. Yeah, it's going back along the X. And then goes down along the Y, back again. It's definitely in reverse. Now, so let's introspect what's going on a bit. So, I don't know what one we're doing. Let's just have a look. There's a bit of a... Oh, crap. Right, this is with my grid. Right, let's analyze this a bit though. So, either way, right? I don't know the orientation of this, to be honest. So there's a 1. There's never 3. Which is interesting. And it seems like the top row is 0, 0, 0. Well, let's look at this sort of coordinate. Ah, interesting. So there is a 4x4 of these. Oh, this is the original. Or here's the block compressed one. But yeah, so the chord, so it's not 2x2. I didn't get that right then in the end. Okay. But yeah, interesting. So why is there 0, 0, 0? Let's go to the top. Then that could be the top left. So many pixels. Ah, yeah. Okay, so it is up here at the top. Okay, so that's 0, 0, 0. So that should map to the max color. Which it does, right? Max color. Right, okay. So yeah, we know this one is basically fine. It's just obviously... Although what's interesting is... So mapping to 0 means you're getting max color. Yeah. And then... So it's always missing 3, which is the third of max. Yeah, that's right. Yeah, that's good. So yeah, at least we're not getting this block at the top, which is great. So let's go back to that shaders. Let's go back to material 2. What should we do a different one? Should we do the volcano one? The volcano one. See how this one looks. Alright. So. Let's see the original texture. Oh, it's meant to be a sandy one. Oh crap. So it's material 2's submaterial 0. That'll be the volcano one. That'll be it. That's pretty funky. It's completely wrong, but it's interesting. See, the original texture looks like this. Before we compress it, there we go. Something better. So, unfortunately though, it's quite smooth. But it's interesting, we can analyze this. So what is that in? So how laggy are we? Sorry, we only lost 10 FPS. It's still a smooth picture apparently, according to people teach you about film in school. Right. That's really weird, isn't it? So that's... Right, that's a pixel. Yeah, these are 4 pixels here. Right. So, oh, so yeah, that's 4 pixels in a 2 by 2, and then so that's a 4. 4 by 4 is this. So, we have yes, there's a 4 by 4 basically in view there. Cool. So we have them printed out. No. Why do I not see? Right. Why is this not printing out? That is the question. Indent it a bit. So let's definitely go through here, right? Let's print out this line here. What's not printing out is all of... Oh, so the indices is 0. Oh, interesting. 5, 5, 7, 4, 8. So that's because they're both equal to the same thing, right? That's not a good block to analyze. All right. Let's just take a look at their min and max code just in case I fluff that up. Yeah, it's just minning. Right, yeah, no fluffing of that. Pretty standard. Right. Hmm. Yeah, so let's try a different block. Let's try one block down. So let's see if we get a different one here. Right, so we've still got a hard-coded sort of... So it's basically saying that all the pixels are the same color. That's what it's saying. But let's see if we can... So after being packed into a 565, they're the same color apparently. So up here, yeah, this doesn't differ that much. That's what it's saying. So ideally, this part of the texture should just be fine. Have a look. Right, it's completely different. See, I feel like maybe if we reorient... this is interesting. If I took this one, this area here, and put that up, and yeah, swap... So this sort of 8 by 4, and swapped it with this 8 by 4, they probably will fit together more seamlessly. Well, these are not, obviously. Right, we're doing a new test now. I got a new test. Got a new idea. My next idea is when we'll generate this grid again. And it'll be a linear color instead of orange across the x-axis, maybe. So we'll do that sort of 2x2 grid again. Maybe we can divide it by 2 such that it's a bit bigger. But instead, this one is going to be based on the x-coordinate of your, so u-coord divided by dims.x u-coord dot y divided by dims dot y. Now I think we have to float cast one of these, obviously. And then we also have to put 1 in the third dimension. Hey, Sully, warm weather this weekend? I don't know. Check my phone about doxing myself on my computer. Maybe. It did get warm last week and then it got cold again. But yeah, it's definitely getting brighter. How's things going, you Sully? How you been? What's going on with dims? I'm seeing dims below, but I'm right. It's just BC dims, maybe. I might do it. Right, the weather says it did hail today, and no, it's about 8 degrees. But next week it might be a little bit warm, a little bit warmer. Alright, so we're getting some slightly different results here. So let's take a look at the uncompressed texture format. Damn it. Is this what I wanted? Red, blue. Why is it red, blue? Oh, I put one in the blue column, didn't I? Right, luckily I can just recompile that. I wanted a red, green. There we go. So, but it isn't technically a gradient if we zoom in. Enhance. What we have is a... Oh, shoot. Right, why is it across the x-axis like that? What are you doing? What are you doing? Oh, yeah. Right, maybe let's not do the stretch. Alright. So it's not wide now. Okay, so 1 pixel, another pixel. Right, so now let's see if this block compresses fine. So you'll have a 4 by 4 set of pixels, like something like this. Hopefully it gets block compressed. Alright, so let's go into the... this one. Aha! We see a problem. So there is some kind of ordering issue with the way... So it might just be the fact that we're reading our pixels wrong. So it's not really that smooth gradient, you see. It should be really green up here. So is this just Morton? It's my Morton swizzling, isn't it? For crying out loud. What a bugger. This whole time. Damn, Morton swizzling maybe. So why is that a problem? So why is this an issue? I'm taking the block. A Morton swizzle block. So it's just a block index. And then it's writing it out using the block index. So damn confused. Right, let's not do the Morton swizzling anymore. How am I going to do this without the swizzle though? I think I've got to manually compute it for a second. So manually computing it will be... Well, I think I've got a thing called like unflatten, isn't it? (2D) dispatch local index.x and the width is 8 by 8 basically. We've got to add SV group index but then scaled by 8 or something like that. That'll do it. This can't be what the problem is. Right, we crashed it. You bugger. Right. XY. Right, see what's going on here. Still same problem. So it's interesting. I don't think it's anything to do with my Morton swizzling then. Like, all right, let's do it the proper way. So it was like BC dispatch index. Not BC, sorry, SV system values. Yeah, XY. So we'll make this an 8 by 8. And that'll do it properly. It's just a standard across the X and down the Y, like a row major access pattern. So maybe it's just to do with the way block compressed formats. Okay, so maybe the addressing in a block compressed format is completely different. Maybe. Or it could be because I'm aliasing my memory in a particular way, maybe? I don't know. Find out. Yeah, so we shouldn't be seeing these cells. It's 8 by 4 cells, we shouldn't be seeing them. Very weird. Right, so it's not to do with this Morton swizzling thing, this thing's completely fine. So what else could it be? Let's take a look at the examples. So when they dispatch there, this is MIP0, I think. So what are they doing? Compress 1 MIP width. Right, it's pretty legit. So if you go back into the block compress header, it's an 8, isn't it? Yeah. There's an 8 by 8. It could be the image layout. And I'm not doing the proper image, the sync code properly. So it could be the fact that it could be the sync code and the fact, though, the way I've decided to alias the memory, it's not done the barriers properly, like the ordering of the memory is invalid. It's not swizzled it or something like this. That could be it. I reckon that's it. So we've got to double check how we're doing it already. So whenever we do our sync code, this is the next thing. So we'll do that sort of like BC1 compress. We've got this sort of compressed albedo, right? And then we say, hey, we're writing to that. So what that's going to do when it puts in the barrier, where's a barrier, for example? There we go. So it goes over. Right. So if the sample is not equal to storage, okay, so it does the sample image, and then it does the storage image as well. Now, I wonder if this is just incorrect. Because the thing is, in Vulkan, you have a very special flag. We might be able to switch it on. And it might fix everything, we'll see. There's a special flag in Vulkan when you create an image. Where, here it is, VK image flag. Yeah, block text or view compatible, something like that. So let's say let's try this out. So let's get the block dims. We'll check if it's block compressed. And if it is block compressed, we'll just throw this on here. Now what this is meant to be for is if we have a texture view, which views the same piece of, which points to the same, sorry, it's called an image view, which points to the same Vulkan image. But we do it slightly differently where we have two images that alias the same memory. And that's to get around a problem with sRGB textures being used with the storage bit. It's not compatible. So I might have to change it the way we do this again and just to test it out. It must also contain mutable format. Damn it. All right. Okay. So it seems like All right. Okay, so I think what I'm going to do is I can't get it working this way. So I think I need... Yeah, so the biggest problem is you can't have a usage storage bit on with an sRGB texture because these are not compatible. So I just alias the memory like this and get it to work. If I create another image. So I think what we'll do is just, I try to combine them to the same thing by calling it a raw variant. But I think I might have a one to say is format sRGB, is format block compressed, and those will just work a bit differently. One will create an aliased image like this, and the other one will create just a different texture view. It's a bit complicated, but it'll get the job done. Yeah, I think that'll be the solution. We'll see. Right, I'll be back in a couple of minutes. Maybe. Right, welcome back everyone. Akraz, my friend, thank you so much. Appreciate you. How have you been? Appreciate the support. Especially for all that time. Like a whole year. Oh, what have you been up to? Right, so I think let's just jam this out. Let's just give it a go, I think. I was thinking like, we'll change this raw variant thing back to being like, is sRGB and is block compressed? Is sRGB is block compressed? And then you want to be able to get out the sort of sRGB unorm variant. And then you want to be able to get out the sort of block compressed raw variant. And those are the two that we're going to basically they're two different features now, they're not a combined set of features. Alright. So that would be a sRGB unorm variant, and then block compressed raw variant. Okay. Rightio. Oh. Now we go. So, in the texture creation code. So, there'll be a few things. So this one be the, if it's sRGB, it does it that sort of way. And the other one is, if it is block compressed, then what do we want to do exactly? We want to say it's immutable format and textile view compatible, something like that. Then do you think there's ways to say like up front, hey, it's only going to be these two formats? And there's ways to, yeah, I don't know. We'll skip that one for now because it's more involved. Okay. So then you create the sample texture. If it is a sRGB texture, we would like to create another texture which aliases the exact same memory, just with a unorm format, but it changes the usage flag, because otherwise it's not possible to alias the same memory as an sRGB texture. It's just so silly. So else it does this thing here. Now we allocate the memory. If it's an sRGB variant, we do it again? No, we can delete all this code now. Yeah, we no longer need that. Allocate the memory, bind it. If it's the sRGB one, bind it to the same memory to the other image. Right, now this is where we need to do that new thing. So we create an image view, right? Now, okay, if it's an, yeah, if it's sRGB variant, or as sRGB, we create the image view for the unorm variant. So we can use it as a storage texture in compute shaders. Nice. Else, if it's a block compressed format, we are going to allow, or create a different image view, which will be targeting that block compressed raw variant. And the image that's going in is, I guess, the storage image. It doesn't really matter, to be honest. Does it? Yeah, that's fine. Cool. Right. Voila. So, anything else? I think there's, yeah, so when you create a texture view, it's got to be careful here, because you can create more texture views. And what is that going to be like? Yeah, I think we want the same sort of thing, right? Yeah, same sort of code, I think. So I think I want to look out for that raw variant code again. Ooh, yeah. Okay, that's good, that's good. So the other final thing is like we want to look for, I think it was like a VK image storage. Yeah. So when they're not equal, it does a delete. So I think a deletion code, let's just get the music back. Right, so it's not an alias resource. If the image, where's the texture view? Oh, I've already got it here. Yeah, if that image view is not equal to that one, delete it. Yeah, that'll work. Alright, so what other places do we do this? And then it's just for this memory barrier thing, which should be... Okay, I think that should be it. So hopefully this fixes our problems. We've just created it, alias using text, image views instead of an image alias in the same memory. Okay, so there's something a little bit off here. Right, so some configuration of what we have is not supported. I bet you it's because we've got the storage image bit on there. How are we going to get this to work then? Right, let me Vulkan info this. Right, hang on a minute. So BC1 sRGB. Right, there is a unorm. Right. Yeah, so we're going to have to use unorm. Oh, this is so dumb. Why Vulkan? Why have you got so much magic which just stopped me from interpreting bytes as something else? Okay, so... Yeah, it only has sample image on it, right? Doesn't have storage image. So we'll bring a support for unorm version. So damn confusing. And then that can be used inside. But you can't use that as a storage image. Anyway. So in our... In the material builder, it should be able to use the unorm texture. And then alias that as a 3232 uint, the vector 2 of 32-bit int uint. And then manually pack that in. So I think what we're going to have to do is remove oh, it's so damn confusing. Units context means linear as opposed to sRGB, which would be gamma corrected when sample correct. Exactly, yeah. Unorm is... Yeah. So basically sRGB, what that does is if you use a sample texture and you sample from it, you automatically get it converted from sRGB to linear in the shader when you sample it. Whereas unorm, it won't do that. Also, if you have an sRGB texture and it's a render target for a pixel shader, it will automatically take a linear color and turn it into sRGB before it packs it into the texture. So these things are kind of cool and kind of nice, but there's a bit of faff around them where you can't have an sRGB texture as a storage image because that's the rules they made up. Like, why can't I just interpret that bit of data as like why can't they just say it just doesn't do the automatic conversion in as a storage image? I would much prefer an inconsistent workflow than one which is completely not usable and restricted. It's so annoying. Yes. So now I've got to try and figure out if some way to design my damn abstraction where I can this is just one of them. So you've got sRGB and unorm, but then I also want to be able to alias it. So I could just say the aliasing happens with an explicit texture view that you make, right? Which is okay because I don't really want this all the time. So, and it will probably be more or less performant if you have aliasing support. It probably turns off certain capabilities on some hardware, maybe. So, what could we do? So I don't know how I've always changed the format, I think. Here's my GPU header. Yeah, I don't have a way to change the format with my texture views, which is another problem now. So it's like, so potentially I should make another format. Yeah, I think this is maybe the way we should do it. I should maybe expose more formats, maybe. Or if you create one as unorm, it creates the alias. Yeah, no. I got me some ideas. Like it should be obvious even if sRGB are just numbers 0 to 255 range. Let me view it. Yeah, exactly. Oh yeah, just running the block compress stuff, yeah. Like why? Like, yeah. If you can basically reinterpret cast a lot of stuff just by changing the buffer type when you access a buffer or stuff like that. But I think textures are a bit special. Well, I think it's sample textures are special, but storage textures are not special. Yeah, sample textures have a bit of magic in there, like they store the format in there, so they can have a bit of hardware accelerated magic that goes on. Like they store it in the descriptor. Yeah, so I think we should add BC. So there was an interesting one where on DirectX they have something called an untyped version. Yeah, I think we should have the unorm version. These guys. But we should probably have the sort of... Wait a minute. So maybe I don't need the raw alias. No, I might need it. Yeah, so let me make another one called unorm raw. And unorm raw will make it such that you have a texture view which has raw the raw access. So when it's a storage texture. Yeah, okay. I think we'll do it that way. So okay, so sRGB is like that. Mm. Yeah, then we have special. Okay, put the sRGBs together. When used as that, you have to manually convert it to linear. So I managed to. Right. Yeah. Okay, so for block compressed, they have a raw variant. Why am I seeing a bunch of SRG? I already had the Unorm variant. Okay. Right, this is great. Hey Dora, how's it going? Welcome, sir. By the way, I asked about the copying the other day. I looked into how it's done in OpenGL, at least historically. And there you need 2 copies, a bounce via the pixel buffer object, and effectively type raises the data as I understood at least. What are you referring to, Cranston? Was this the something from the stream the other day? I think I'm missing some of the context. Was it in relation to some? Yeah, I'm unsure. For block compressed textures, when you use a sample texture, the pixel will automatically decode it. Right, for star. It's already unorm. But yeah, we're saying for underscore raw. They will automatically be decoded from the compressed block when used as a. You work on the raw pixel block data. This is useful. Yeah. This is exactly what I want. So we'll have a raw variant of these basically. Yeah, let's just copy paste and write the word raw after it. This is the way I want it to work. Something about the lines of what does a text copy do? Do you have one in code? Right. I see. Right. Yeah, that does sound it. Alright, I reckon that'd be ideal. Alright. So we need to add raw variants. I think we need to have like an is block compressed raw. Maybe that'd be another one. Will there be more? Oh, there is. Tons. Can't find a good tutorial. I thought I ventured to go my bookmarks. My only bookmark is that good. So Not So Red has a good. He's got his resources where he looked at the bottom. That's what he used when he did it. I'll link it again. You can also look at Not So Red source code and read it and see what's going on. Why are GPUs so complicated? It's supposed to be easy. Why can't I just view memory as anything I want? Why don't you do all this? Ugh. Okay, so I reckon we need. It'd be nice to have this is block compressed, but also it'd be nice to have is block compressed raw. This is actually what we're going to need to use. Oh. Right, and this raw variant. We'll map a raw to one of those. Amazing. So it's got to take this, stick it in the header file, otherwise it won't be publicly available. Then go into GPU Vulkan. Now let's fiddle around with this a little bit more, do a bit more code massage. Because the previous massage didn't get in the right place. So, if it's block compressed raw, yep. Say we're going to do some special alias thing. Create the alias. Amazing. So, what does this mean? Well, it means then in our graphics code where we do our BC1 sRGB thing or whatever it is, these have to be replaced with unorm raw. No. Right, this is the material cache. This is runtime when it's already loaded into memory, ready to go. That's sRGB. When we're making stuff to edit, I guess, this one needs to be unorm raw. Then, if we're compressing, it has to be unorm raw. Did I see a BC3 for a minute? Oh, BC5. Good, good, good. Yeah. Very nice. So that should run now. We're crying out loud. What's going on there? Did I not close something? Whoops. I didn't know. Thank you so much. Ah, here we go. Oh, right, doubled it there. Right. Whoops. Oh, you know what I might have done? I had the multi-line going. Ah, damn it. I had my multi-line cursor. So I must have done the multi-line, scrolled up, and gone somewhere else and done another multi-line, and then it would have just kept going off the screen, basically, in editing. Not very fun. So I think I've duplicated it to some degree. Right, so unorm, snorm. Excuse me. And get rid of that one as well. There we go. That's very dangerous. We'll check. I'll check the git diff at the end to see if I broke it. Right. Hello chat, hello streamer. I would like to know from which distribution you recommend to install my home PC for daily tasks like games. Right, so the easiest one to use is probably Manjaro. I'll recommend that because these ones are set up. It's Arch based, so you can get somewhat latest packages and stuff. It's pretty neat. I wouldn't suggest Ubuntu. It's always had problems for me. Some people are fine with it, but I've always got issues when I use it. But yeah, that's probably the best distro to use. Oh, 2000 odd. Okay, have a look. And what file though? $2,600. I don't have that in this. Yeah, I don't know. Right. So, BC1. Why is BC1 being created with, or sRGB being created with Yeah. Why has it been created with storage? It should be part of the sRGB club. Aha, it's not. BC1 sRGB, BC3 sRGB. No need there. Unorm variant, which is GPU BC1 unorm. 3 unorm. Voila. Alright, that should do it. Crap. Hey. Right, this one's complaining because why? It's still got the storage bit set on. Oh, interesting. This one's saying that BC RGB unorm. This one might not support storage bit at all. It's pretty crazy. So we can look at that again. Vulkan info, BC1, RGB. Yeah, so apparently it doesn't support as a storage format either. Yeah, of course, because you wouldn't be able to write to it. It makes a ton of sense. So in that case, we would... What would we do? It can't be used as a storage texture at all. Ah. Okay. So in this case, you say sRGB and it'd be unknown. Got it. So that means in the Vulkan side of things, we have to say it. And so if this is not equal, format none, then create yourself that image. Now I want to do that in a few other places as well. So it won't have a storage image. Yeah, so storage images might not exist now. There's something to keep an eye out on. So by memory, so there's sRGB only if it exists. Just aliasing again. Right. If sRGB, get rid of storage, alias. You only really alias if that is like that. Okay. Cool, nearly there. So we'll look at every usage of storage image now. The storage image might not exist anymore. So there's a deleting. Yeah, so if the storage image doesn't exist, it needs to be the null image really. Kind of. You need to set it to the null image, I think. So really we should set, then if it's the null image, I think I've got it in GGPU Vulkan. Null image view. No, we technically need that. Here as well. I'm just wondering if I should just keep these as null. This should be storage. Okay. So if you storage images a bit more. Now when we delete them, we've got to say if they're not equal to the null image. So it's going to try and name them there. Bit annoying. Oh well. Probably just going to try and name them, isn't it? That's the issue. So we only want to name the storage image if that's not equal to GPUVK null image. Something like that. We're probably going to need that same if statement down. Yep. And then I think it's just in the defer delete. We only want to defer delete these if this is not equal to VK null image. The same for the image view. I just made it a little bit more confusing, but there you go. Right, let's give that a go. BC5 is complaining now was that it's getting sampled and storage bit enabled. Right, so really we should be saying if it's block compressed at all, don't allow storage image. That's the logic we're looking for, really. Yep. Okay. Right, this one's a little bit off. GPU VK null image. Right. So here we go. When we create the image, we've done a new one now. If it is block compressed, that's all. No, it's nothing. It was block compressed raw. We want the sample image as the storage image. Don't we? Hang on a minute. How did BC1 Unon work then? Right. Yeah, I'm a little bit confused on why that's not working, because... Or, sorry, I'm a little bit confused on how we can make this possibly work. We're not allowed to use it as a storage image. So how can I create it and alias the memory? Right, that's something I'll just think about off stream. I think it's getting a bit late now. I'll put a pin in it here today, but hopefully we get this working next time. Yeah, so the next objective is try and do this memory aliasing properly with the proper flags, because we wasn't doing that before, and I think that will solve our corruption issue. It seems like the memory's corrupted in some way when we're writing out the blocks. There's some kind of sync issue, and this is the crux of the issue, I think, with our block compression code at the moment. Right, so yeah, in the meantime, guys, there is a Discord on Hangout. If not, the next stream will be Sunday and Tuesday. There's a Twitch timeline if you want to check out that for the exact times in your time zone. Next Thursday is my birthday, so I won't be here. I'll take the day off. So, yeah, until then, guys, I'll see you all in a future one. Thank you all for coming by. I'm going to go and crash in bed. Hopefully get a reasonable sleep. Alright. So let's let raid last miles. Right, guys, catch you all in a future one. Have a good start to your weekend, and I'll see you all very soon. Bye-bye.